All right, welcome to another stream. Welcome to Caveman Coding. Today we will be learning about process groups and process sessions. So that'll be one, and next we will learn about demons, and yeah. So without further ado, let's just start. So the first thing is that hold on 1 second. Okay, so let's just start. So process group and sessions. Each process belongs to a process group. A process group leader is the process whose PID is equal to process group ID. So any process must belong to a process group, and process group leader is the process whose process ID is equal to process group ID, which is like common sense. And a session is a set of process groups. So a bunch of process groups is a session. So makes up a session. A session leader is the process which creates a session. A new session is created using the system call set SID. Um, so using the system called set SID. So a new session is created using the system called set SID. Use of process group leader in wait PID function. If PID is equal to 0, the parent waits for any child of the process group to terminate. That's cool. In kill function, if PID is equal to 0, the signal is sent to all the process of the process group for which the sender has permission. So in kill function, if PID is equal to 0, the signal is sent to the all processes. Okay, that's cool. Of the process group for which the sender has permission. So this slide tells us about the wait PID and kill function in terms of in terms of process group scenario basically. So in wait PID function, if PID is equal to 0, the parent waits for any child of the process group to terminate basically. So any child of the process group to terminate, it waits for it. And in kill function, if PID is equal to 0, the signal is sent to all the processes of the process group for which the sender has permission. Uh, that's cool. The signal is sent to all the processes of the process group for which the sender has permission. So basically, it deals with the same process group. The processes in the same process group um, are um, are affected by the kill and wait PID functions. So the next thing is set SID is where you use to create a new session. Is how you create a new session. I'm sorry. So if the calling process is not a process group leader, this function creates a new session. Three things happen. So if the calling process is not a process group leader, because a process group leader um, belongs to a process and it cannot create a session. I'm not too sure, but let's just read on. The process becomes a session leader of this new session. Okay. The process becomes the process group leader of a new process group. Yeah. So this is the condition that is haunting this condition basically this factor. So it should not be a process group leader because when the function creates a new session, the process becomes the process group leader of a new process group, and the process has no controlling terminal. Yeah, so three things happen. The process becomes the session leader of this new session. The process becomes the process group leader of a new process group, and the process has no controlling terminal. Interesting. The process has no controlling terminal. The process becomes the process group leader of new process group. Nice. Becomes session leader of this new session. That's cool. And then the controlling terminal, daemon process. Okay, so controlling terminal. A session can have a single controlling terminal. The session leader that establishes the connection to the controlling terminal is called the controlling process. Process groups within a session can be divided into a single foreground process group and one or more background process groups. So the session leader that establishes the connection to the controlling terminal is called the controlling process. The process groups within a session can be divided into a single foreground process group. Nice. One or more background process groups. Whenever we press the terminal's interrupt key, often delete C or control C, the interrupt signal is sent to all the processes in the foreground process group. Nice. Whenever I press the terminal's quit key, control backslash, the quit signal is sent to all the processes in the foreground process group. So whenever we press the terminal's quit key, quit signal is also sent to all the processes in the foreground process group. So whichever signal is sent to process, it will be sent to the foreground process group only. So let's just read upon sorry, let's just read upon this, right? This very good blog by this person. I'm not too sure how to pronounce this, so I'm not gonna try, but yeah, it's a very good article, so I'm just gonna read it. So process group jobs and sessions. A new process group is created every time we execute a command or a pipeline of commands in a shell. Inside a shell, a process group is usually called a job. So in its turn, each process group belongs to a session. Linux kernel provides a two-level hierarchy for all running processes. Look at image 3 below. This is image 3. Hmm. Okay, Linux kernel provides a two-level hierarchy for all running processes. Look at image 3. As such, a process group is a set of processes, and a session is a set of related process groups. Another important limitation is that a process group and its members can be members of a single session. As such, a process group is a set of processes, and a session is a set of related process groups. Another important limitation is that a process group and its members can be members of a single session. Okay. Process groups. A process group has its own process group identifier PGID and a leader who created this group. The PID of the group leader is equal to the corresponding PGIDs, and as so, the type of PID and PGID are the same, and is PIDT. All new processes created by the group members inherit the PGID and become the process group members. In order to create a group, we have set PGID and set P groups is syscalls man to get P group. Um, so process group has its own process group identifier PGID and a leader who created this group. That's cool. So it has a process group identifier PGID and the leader who created this group. And so the leader, the PID of the group leader is equal to the PGID. So the type of PID and PGID are the same, which is PIDT. All new processes created by the group members inherit the PGID and become the process group members. Nice. In order to create a group, we have set PGID and set P group. Okay, that is cool. Process group lives as long as it has at least one member. It means that even if the group leader terminates, the process group is valid and continues carrying out its duties. So even if the process group leader terminates, the process group is still valid and continues carrying out its duties. A process can leave its process group by joining another group, creating its own new group, and terminating. So to create its own new group, I don't think it should be a PGID as its PID, which means that it should not be the process group leader beforehand before creating its own new group and joining another group. Oh my god. So you can leave by joining another group and then also by terminating. Also by terminating. So Linux kernel can reuse PIDs for new processes if only the process group with the PGID doesn't have members. It secures a valid hierarchy of processes. Can reuse PIDs of for new process if only the process group with that PGID doesn't have members. Let me read it again. Linux kernel can reuse PIDs for new process if only the process group with that PGID doesn't have members. It secures a valid hierarchy of processes. Um, can reuse PIDs for new process if only the process group with that PGID doesn't have members. Okay. Um, I'm not too sure about this though. Let me think. Creative for new process if only the process group with that PGID doesn't have members. So the process group doesn't have members, and the new PID, if it is not equal to the PGID of the process group, then only it can create. Okay, that's cool. Understood, I think. Which means that a PGID is unique in a sense that in a process group, the process group leader is only the uh, is only the process. Um, I mean, in the process group, the process leader has the project process group ID, which is unique to the process group, so that uh, y- another process, for example, which has a PID equal to PGID is not allowed. So a new process cannot have the PGID. I think that is what this sentence says. So it secures a valid hierarchy of processes. Okay. A leader of process group can join another process group because the constraints between PID of the process and PGID of the process members of the group will be violated. A leader of a process group can join another process group because the constraints between PID of the process and PGID of the members of the group will be violated. A leader of the process group can join another process group because the constraints between PID of the process. Yeah. Okay, that's interesting. Two interesting features of process groups are because I you can understand leader process group can join another process group because the connection between PID and the P and other process and the PGID of the members of the group will be violated because if you think about it, a leader of the process group has a PID equal to PGID, and when it if it ever leaves this process group and joins another process group, um, its PGID will be set to itself, which is its PID, and so leader process group can join another process group because, well, let me break it down. If this PID will be equal to PGID, and PGID means which means that it's unique, and damn it, boy. Let me just. I'm not too sure about this sentence. Constraints and process group leadership. A process can only be lead of one process group at a time. This is because the leader of the process group has unique relationship with the group. Its PID serves as a PGID for all the members of the group. Process can only join a new process group. Doing so does not cause its own PID to conflict with the existing PGID in the new group. Um, nice. I think it's better to take an example here. Here, a process say with PID 1234 is a read with process group PGID 1234. Its PID is a group ID. It cannot join another group whose PGID is also 1234 because, well, obviously cannot join another group whose PGID is also 1234 because that would violate that the rule that a single PID cannot be the leader of more than one process group at a time. Yeah, obviously. If it tried to join such a group, the system would result the operation the process would not be able to join. Nice. So process group leader model is designed to maintain clear and consistent group structures and the constraint to prevent the process leader from joining a new group if it would conflict with the current group's PGID. Um, yeah, because first of all, it cannot be 1234. The process group's ID. Yeah, because let me see here. PGPID 200, 300. So let's say if this process group leader, this particular process group leader tries to join here, well, to be part of this process group, its PGID should be 300 and it's not. So how does it even join then? Um, and and because this process group ID is unique to this process group, I'm not too sure about it. Can you explain it more clearly? A system has unique identifier called PID. PG is a group process group that can be managed together, particularly for signal handling. For example, sending a signal like SIGTEM to a process group will send it to all persons in that group. Similarly, the PID is the leader of the process group. In other words, PID becomes a group ID that identifies the entire group. Leader of process group. Leader is the process that created the group. This process PID is used as the PGID for all processes in the group. Key rule: a process leader can only be in one process group at a time. Exactly. This process of PID serves as the PGID for that group. Every process in the group shares the same PGID, which is the PID of that leader. Of the leader, a process can only belong to one process group at a time, and that process PID must be the PGID of that group. So, a process can only belong to one process group at a time, and that processors and that process PID must be the PGID of the group. Let's say you have a process with PID 1234 and it is the leader of a process group. This means the process group's PGID is also 1234. Um, yeah, if you try to move that process with the leader group into another process group, is what happens. The process cannot have two PGIDs because there is a conflict. Each process group has a unique leader with its own PID. Yeah, yeah, I got it. Because to qualify as a process group leader, its PID should be equal to the PGID. And when because this particular leader, has a PID which is equal to PGID, join another process group which also has another process which has a PID equal to the PGID. Um, there lies the conflict because um, yeah, exactly, there lies the conflict because the PGID will be different for the two process group leaders if it can join another thing. Yep. Its PID would become the PGID for the new group. Yep, yep. But it's already the PGID of the current group. This will cause a conflict because same row cannot be the leader of two process groups at once. Nice. Um, nice, nice. Got it. So two interesting features of process groups are a parent process can wait for its children using the process group ID. Yeah. So interesting features of process groups mainly is basically to send a signal. So a parent process can wait for its children using the process group ID, which means that it will wait for all the children which are included in the process group using the process group ID. That's cool. A signal can be sent to all members of process group by using kill PG or kill with a negative PGID parameter. A signal can be sent to all members of process group by using kill PG or kill with a negative PGID parameter. The below command sends a sig term to all members of the process group 1, 2, 3. That's cool. So it'll send kill basically minus 15 1 sorry, kill hyphen 15 hyphen 123. Send this signal 15 to the process group which has a process group ID 123. So we have two long running steps in process group if it's created for automatic shell connected by pipe. So it has a signal handler. That's okay. Signal as a signal which takes in the signal handler function here and handles this signal sigterm, and the PGID is whatever. Okay. Saw the pipeline and in the middle of executing running kill command in new terminal window. So you have compared both of these files. So PGID is 9743. So 0 1 2 3 signal number 115 kill it by specifying the PGID. So the main thing is you can kill you can send a signal to all the processes in the particular process group. Basically, that is the core. Now, if we go to sessions, first part of the session is collection process group. All members of session identify themselves by the identical SID, just similar to the process groups. It's also the PID type, and as a process group, also inherited from the session in which created, and as a process group, also inherited from the session leader, which created the session type, which is all persons in the session share a single control term. We will talk about this later. This is important. I think all processes in this session share a single controlling terminal. Interesting. New process and its parent session ID in order to start a new session. Um, 1 second. I'll be back. So, all process in the session share a single controlling terminal. Interesting. A new process inherits its parent session ID. In order to start a new session, a process should call set SID. A new process inherits its parent's session ID. Okay, nice. So it'll automatically belong to the same session. In order to start a new session, a process should call a set SID, which is man to SID. The man page for the set SID is there. The process is running. The syscall begins a new session, becomes its leader, and also becomes its session leader too. Nice. SID and PGID is set to the process PID. That's why the process leader can't start a new session because, well, process group leader can start a new session because, well, the process group could have members and all the members must be in the same session. Yeah. So the process group could have members, but all these members must be in the same session. So new sessions created in two cases: when we need to log in a user with the interactive shell, or shell process becomes a session leader with the control terminal. About this later. A daemon starts and wants to run its own session. In order to secure itself, we will touch daemons in more detail later. The following image shows the relation between session, process groups, and processes. So process group is here, which has 100, which PID is 100, PPID is 99, PGID is 100 as expected, SID is 100 because it is a process group leader, and the session ID will be equal to the PID for the process and also equal to the PGID of the process group because it's the leader. PGID, so foreground process and the background group. So the foreground process group says the PGID is 200, so the PID, this is the process group leader for this process group 200. So PGID is 200, SID is 100 because it belongs to, all of these process groups belongs to the session ID 100. So, and WCL, another process, and if this says PID 201, SID will be 100 again, PGID will be 200, PPID will be 100 because parent is 100. Okay, again PPID will be 100 here, PPID will be 100 here, PID is 300, this process group 300 basically, PGID is 300, and this is the process group leader. This 300 will be the PID and also the PGPID of this process group. SID will be 100, SID will be 100 because all of these process groups belong to the same session. So session ID is the same as session leader, process PID. The session leader has its own process group, whereas the leader, the session leader process has its own process group. Yeah, session leader process um, has its own process group where it's a leader. So PGID is the same as the PID. The session has two more process group with PGIDs, 200 and 300. Only one group can be foreground for terminal. All the process groups are background. We'll touch on these terms in a minute. All members of session have a pseudo terminal dep PTS0. In order to get all the members of and was, we can read the proc PD stat, this thing, PID 415 PPID. Okay, process group ID, session ID. That's cool. Control terminal of the process. Control terminal, control the process, foreground and background process groups. My god, that's a lot of things that has been covered in this. So control terminal, control process, and foreground background process. In control terminal is a terminal that controls a session. Simple. So controlling terminal is a terminal that controls a session. There may not be a controlling terminal for a session. It is usual for daemons. So 1 second. we're back again. Sorry for the interruption. I had something to do. Okay, well, control terminal. Oh yeah, so we were reading this, right? So a control terminal is a terminal that controls a session. They may not be control terminal for a session. It is usually for daemons. In order to create a control terminal, at first the session leader, usually shell process, starts new session with set SID. Yep. This action drops a previously available terminal. If it exists, then the process needs to open a terminal device. On this first open call, the target terminal becomes the control terminal for the session. Nice. From this point in time, all existing processes in the session are able to use the terminal 2. From this point in time, all existing processes in the session are able to use the terminal 2. The control is inherited by fork call and preserved by exec. A particular terminal can be the control terminal only for one session. Um, so So yep, on this first open call, the target terminal becomes the control terminal for the session. Um, yeah, so firstly, the set SID will drop a previously available terminal if exists. Then the process needs to open a terminal on the first open call. The target terminal becomes the control terminal for the session. From this point in time, all existing processes in this session are able to use the terminal 2. The control terminal is inherited by fork call and preserved by exec. A particular terminal can be the control terminal only for one session. A controlling terminal sets two important definitions: a foreground process group and a background process group. Let me just highlight this. Okay, so control terminal sets two important definitions: a foreground process group and background process group. At any moment, there can only be one foreground process group, and for this session, any number of background ones. Only process in the foreground process group can read from the control terminal. Okay, nice. So only processes in the foreground process group can read from the control terminal. On the other hand, writes are allowed from any process by default. There are some tricks with terminals. Um, okay, can read from the control terminal. On the other hand, writes are allowed from any process by default. There are some tricks with terminals. We touch them later. We will tell solely about terminals. A terminal user can type so special signal generating terminal characters on the control terminal. The most famous ones are Control C, Control Z. As its name suggests, a corresponding signal is sent to the foreground process group. By default, Control C triggers a second signal. Control Z, a STP signal. What is that? I don't know. But also opening the control terminal makes the session leader the controlling process of the terminal. Okay. Starting from this moment, if a terminal disconnection occurs, the kernel will send a sig hang up signal to the session leader, usually a process. So if a terminal disconnection occurs, the kernel will send a sig hang up signal to the session leader, usually a shell process. The TC shet PGRP is a libc function to promote a process group to the foreground process of control terminal. There is also the TC set P group function to get the current foreground group. These functions are used primarily by shells in order to control jobs. On Linux, we can also use IOCTL. Let's try to skip that. Emulates the shell logic of creating process group for the pipeline. Create the first process in the shell pipeline. 1 second. It'll just come. Alright, so um, well, going over this will be good, but if you press Ctrl C to terminate the process, we'll stop only the parent with PID 8248429. It happens because in the process, in yeah, I mean, from the perspective of the control, all was in the 8430 group will continue running in the background. So if they try to read from the terminal, will stop by the controlling terminal by sending them a SIG-TTIN signal. Nice. It is also trying to read from the control terminal without acquiring the foreground group. If we log out or close the control terminal, this group will not get SIG hang up signal because the batch process controller doesn't know that we started something in the background. Oh damn. Nice. So the SIG hang up signal will only be sent to the foreground process group. In order to fix the situation, we notify the control terminal we want to run another process group in the foreground. Nice. So okay, that's where we do, but it's not required for now. Shell job control. So here what we're doing is it's creating a new process group with PGID of the first process in the group, puts this group in the foreground group by notifying the terminal with um yeah, nice. um Process group is also known as a shell job. Yeah, skill is basically shell uses usually allows to kill jobs by the job ID, so we need to be able to resolve internal job IDs into process group IDs. Allow users to send signals to process if the system has the max running process limit. Terminating shell. Yeah, a lot of stuff here, and then Daemons also. So damn, bro. So uh, let's just tally a thing to the slides. Let's read it again. Um, okay, so that's what you have read. Process becomes the session of this new session. The process becomes a process group leader of new process group. The process has no control terminal. Yeah, yeah. So a session can have single control terminal. A session leader that establishes the only the session leader can establish the connection to the control terminal is called the controlling process. Nice. The process groups within a session can be divided into single uh, foreground process group and one or more. This is done by the control terminal basically. Whenever I press the terminal interrupt key, often the interruption is sent to all process in the foreground process group. Daemon processes properties of a daemon. It is a process that starts at boot time and runs in the background. Um, Alright, I mean that's cool. It's a process that starts at boot time and runs in the background until the system is shut down. Nice. It has no control terminal. So daemon has basically it doesn't. One more thing I want to read again is this point that basically to create a new session can be done in two ways. That what yeah here when you log in a user with an introduction shell process becomes designated with a control terminal. Okay, that's cool. A daemon starts and wants to run its own session in order to secure itself. A daemon starts and wants to run its own session uh, in order to secure itself. So what it says that a session can have a control terminal or cannot have a control terminal, but a control terminal is always associated with a session. Nice. It is a process that starts at boot time and runs in the background until the system shut down. Has no control terminal. RMS is logged using the syslog daemon. Examples are all the standard services. Daemon creation steps. Call umass to set the file mode creation mask to a known value, usually 0. So umass to 0 basically. Call fork and have the parent exit. So this ensures that if the daemon is called from the shell thinks the command is completed. Secondly, the shell will not be the process group leader. And only then we can create a new session, right? So an already existing process group leader cannot create a new session, so that's why we will do fork. And also this ensures that the daemon is called from the shell. The shell thinks the command is completed. Interesting, but I'm not too sure about this sentence. So call SID to create a new session. Change the current working directory to the root directory. Unneeded file descriptor should be closed. After this thing, call for another parent exit. We need to do call set SID to create a new session. Change the current working directory to the root directory. Unneeded file descriptor should be closed. Unneeded file descriptors should be closed. Some demons do descriptor 0122 dev null. With this is because the demon is not associated with a terminal. That's cool. Ignore the sig hang up signal also, because if it's basically sig hang up signal is when basically a terminal uh, is disconnected, control terminal is disconnected to session. That's when the sig hang up signal comes into play. uh, if so, the hang up signal comes into play, and if it receives it, then it means that, well, it's associated with the terminal. And I'm not too sure about this reason though. So basically this is the initialization function. Basically PID fork, you do set SID and then ignore sig hang up signal, ignore set it to sig ign, and PID is going to fork exit 0. You're doing a double fork basically. Change to root directory, umass 0, close all unneeded file descriptors, return 0. And syslog function, oh damn, there's a lot of stuff here. Is a function that allows daemons to log different types of messages to help with the debugging and troubleshooting for a system and service. Okay, it's a function that allows daemons to log different types of messages that help with debugging or troubleshooting a system service. The prototype syslog is in priority, char format, and can be more char formats basically. Priority is a combination level, and facility the message format. The message format is as in a printf. Slog, log, crit, um, warning, info, debugger some levels, facilities, logout, cron, user, daemon are some facilities. So syslog d daemon basically, it is a file in this etc syslog.com to determine what to do with the log messages it receives. A Unix domain socket is created and bound to this path name var log messages or var run log etc. depending on the OS. So etc syslog.com to determine what to do with the log messages it receives. Okay. Unix domain socket, and then a Unix domain socket is created and bound to the path name var log message var run log etc. depending on the OS. A UDP socket bound to port 5 and 4 is open. A path name var klog is open to which the kernel sends error messages. Um, it was the kernel sends error messages. UDP Sagraban to port 514 is also open. Is the daemon to which the syslog function sends messages. Okay, the syslog function in turn sends messages syslogd. Kernel routines can call log function. These messages can be read by any process that opens and reads the dev klog. Most user process daemons call the syslog function to generate log messages. This causes message to be sent to the Unix domain datagram socket devlog. Um, syslog D reads the device's klog and writes the messages sent to these devices typically to a file again. Nice. Modification for the entity super server. Um, wait flag in the entity. Let's just read. A lot of network servers run as daemons in server system. Most of the process block state most of the time, but occupy slots in the process table. All these daemons have to go through all the steps to create a terminal daemon, thus replicating the code in every server daemon. Yeah, so all of the network server daemons run as daemons basically. So all the network server process, most of these process block unblocked most of the time because occupy slots and in the parser, and all these daemons have to go through all the stuff to create a daemon, thus replicating the code in every server daemon. So allows efficient writing networks by simplification writing daemon process allows a single process to wait for clients multiple services instead of multiple processes, most of which are idle. Nice. Um, Harnesses are stated in the config file. Okay. So flowchart for and super server listen select accept fork. So basically you're using select and then fork at parent and then child close all the scripts other than socket to socket 0 2 2 1 2 2 socket to descriptors 0 1 2 so that you can log basically close socket xx server close connected server. Nice. So telnet init configuration file stream tcp wait is good to know root yes parent stores the PID of the child and then say child handler checks for this PID. Yeah, I mean it's not actually needed, but raw sockets and stuff like that. So yeah, so I think the reading part is done. I'll just see some of the code now because let's just do some code. See if you think about the advanced IO. Well, this one we will do the code part of demons and the control terminal and process groups and sessions in the next stream, which is tomorrow. But for now, let's just do this advanced IO. Everything about this message.header, all these files are okay. netdb.h slip string socket types units today. netinet slash in.h netinet slash in.h netdb.h is also there. arpa slash inet.h net inet slash I not in dot h std int dot h that's interesting. All this I think it's needed std int dot h to I think typecast an into void I mean void pointer to an int sys uio dot h message header dot h. If you look at the message header thing, um if and if message header underscore h hashtag define message header underscore h, hashtag include stint dot h. Okay, nice. So unsigned short message number, uint 32 bits client ID, short for message number. So all of them are unsigned, which means that um, they're only positive numbers, and they'll wrap around zero after reaching the limit. Unsigned char opcode message header. Nice. So you're basically type defining this structure to message header. Um, cool. Hashtag end. Nice. Now after that, you just include the include statement here. You do this. This is mostly common. You initialize a struct of message header here. Okay, nice. Um, buffer size to socket FDs. Two of these. Of obviously this socket basically to listen FD. You can also do memset instead of this. Syn family a finet. Address will be argv1 as a server, but I don't know why it was a server. Why is there two arguments though? This is wrong. Actually, this should only be two, and the address here should actually be in add any. So yeah, that should be it. Like, H2NL probably. Port should be 1. Then you bind it on the server address, basically listening on this port on all of these, on all of the addresses, on all of the interfaces basically. And then listen for maximum clients of 15, service started, and while 1 you accept the connections on the client address, basically on the client length, basically pretty cool. Connectivity again. Now basically in message number 1 less than 3, message number plus plus, if message number is equal to 1, you do read. I think it's just to read and receive is just to basically um, showcase that we can use both of these functions, header or client ID, end to HL. After receiving, you do end to HL, obviously, end to HS, obviously, because you're storing it in header, which you have defined it, which you have defined here, right? Where have you defined it? Um, you have defined it here. Nice. So you define it there, and you're basically reading it to the header file, and conmd buffer plus total received, buffer buff size minus total received, and pretty much this thing. Header.opcode is 2, and then you're basically going here. um Pretty cool. But the same thing can be achieved by using the vector IO. Vector IO, I think it's this includes statements slash uio dot h vector IO. Basically, it should be two again. All of these is the same until this is wrong. This should be in any. That should be one. And listening on that, and then you're doing struct io vec iov2, one for the first struct in the array is for the header, and the second struct in the array is for the buffer. Pretty much you have initialize those things. And readv conft from conft, you have basically putting into iov, basically receiving it all at once basically. Nice, I got it. And then the count of the array of this is just 2, and then you're just formatting it correctly, and pretty much that's cool. Header dot opcode is 2, as to as header and again you're sending these things again back to, so you're basically send iov and header size of header buffer size, and then you're writing into send iov, right, using write v, send data using 0 to x, which is hexadata, and you are basically unsigned char. You're basically typecasting into unsigned char for the buffer, and then server sent ld, which is long integers, because I think byte sent was sist. You can also do percentage d, but it's like when you're using sist, which is larger quantity than integer, it's better to use ld. So that's how you use vector IO. It's cool. Get ip, I think we have to implement it in the next stream. We'll try to do it tonight if after dinner. We'll come back, but as of now, that's it for now. Thank you for tuning in. Thank you for tuning in, boys and girls, and I'll see you in the next stream tomorrow or today. I'll try to do it today. Bye.